One construction method has achieved success in the practical application based on the coring theory in hard ground. It exhibits the superiority of the press-in method to the fullest extent. This method is called the hard ground press-in method. In the press-in method, sheet piles are simply pressed into the ground with static load, or high-pressure water is used as a driving assistance for standard press-in. However, these methods face difficulties at hard gravel layers and bedrock, where SPT values exceed 50. The hard ground press-in method overcomes such difficulties by simultaneously operating a special augering attachment with press-in. Development of the hard ground press-in method started in 1975. It was when the silent piler was put into practical use for the first time in the world. The first silent piler was designed so that augering equipment could be attached in the future. After the silent piler became popular in the market, GIKEN continued to develop hard ground press-in technology, including field testing. Then in 1997, the SuperCrush SC100 was born and put into practice the unique coring theory, established from accumulated knowledge and technologies. It was then subsequently introduced into the market for the first time as hard ground press-in equipment. While the market for hard ground press-in equipment has become more demanding, a new hard ground press-in machine, the SuperCrush Piler Type M, was introduced in 2001. Among the latest silent pilers, Echo 400S has been introduced as a versatile press-in machine, capable of piling for hard ground, with water jetting and standard press-in by single silent piler. The hard ground press-in method has been registered in the New Technology Information System, so-called NETIS, which is conducted by Japan's Ministry of Land, Infrastructure, Transport and Tourism, where this method has been regarded as a superior technique to traditional piling methods. Furthermore, in 2008, the hard ground press-in method for U-profile sheet piles was certified as being a standard piling method in the MLIT's Civil Engineering Estimation Standards. There exists many piling methods that use augers. With the press-in method, the auger torque can be transmitted into ground without any loss of power because the press-in machine firmly grips the reaction piles to be stable. Press-in force can be transmitted more accurately to the pile toe compared to conventional piling methods because the press-in machine clamps are sited very close to ground level. Establishment of the coring theory has made press-in work in hard ground possible. While the pile is being pressed in, a pressure bulb is generated around the pile toe. This pressure bulb forms of compacted chunks of soil and becomes a pile toe resistance force, which obstructs pile penetration. Under the coring theory, the core of the pressure bulb is excavated by an encased auger to prevent the pressure bulb from obstructing the pressing operation. The pile is then pressed into the excavated space. Thanks to the coring theory, the press-in method can achieve penetration into hard ground while keeping ground disturbance to a minimum. Furthermore, the GRB system can reduce the environmental burden in any construction site by not requiring massive temporary works. This system received an Environment Prize in Japan and is widely acknowledged as an environmentally friendly piling system. Based on the advantages of the coring theory and the GRB system, GIKEN is capable of providing construction solutions for site restrictions and difficult ground conditions all over the world. Various models of the SuperCrush piler have been developed for different types of piles. The piles that can be accommodated include U-sheet pile, tubular sheet pile, Z-sheet pile, precasted concrete pile. Zero clearance piling is possible with zero sheet pile. and H-sheet pile. Here is an example of the Super Crush Piler, which is designed for installing U-sheet pile. Let us review the machine specification. The Super Crush Piler is a silent piler that is combined with a pile auger composed of the auger motor and casing auger, which is attached to the main body of the press-in machine. The ground is drilled with a pile auger, while simultaneously the press-in operation is performed. This Super Crush Piler is the latest environmentally responsive construction machine. The noise level shows minimal values amongst construction plants. The emissions levels comply with the standards of Japanese and American Tier 3, plus the European Stage 3 off-road law. In addition, plant-based biodegradable oils are used as the standard hydraulic oil and grease in the Super Crush Plier. This minimizes the risk of negative impact to the natural environment. For piling management technology, the equipment's mechanical conditions are monitored at each site through an IT system at a support center. Any potential problems at the construction site can be prevented before they occur. In addition, there is a measurement function used for the press-in control data. The optimal piling operation is achieved by preventing excessive load on the piles by measuring the penetration resistance during installation. The necessary equipment for a standard piling site is comprised of a Super Crush Piler, a power unit for driving the press-in machine main body, a service crane, and a mini backhoe for taking care of displaced soil. When a service crane cannot approach the construction site, piling can still be performed in narrow spaces, slopes, and over water by using a clamp crane that moves atop the installed piles. The piling procedure begins with installing the press-in machine main body onto the reaction stand. Counterweights are loaded onto the extended arms of the stand, and all weight is then utilized as reaction for pressing. A sheet pile is then pitched along the casing auger, where it will now be pressed in with simultaneous augering. Such installed piles are utilized as the reaction pile to press in subsequent sheet piles. The piles are pressed into the datum level. The casing auger is then pulled out. The drilling diameter and the amount of soil displaced are kept to a minimum to prevent negative influences to neighbors and to effectively reduce the penetration resistance force required for pressing. Once the bearing capacity of the pile being pressed in is confirmed, the press-in machine main body is raised and moved forward. By gripping the reaction piles, the press-in method fundamentally solves the hazard of the machine tipping over, while still being able to perform hard ground piling within a compact machine. The range of applicability for the hard ground press-in method includes gravel layers with large boulders and bedrock, for which coring press-in cannot be used. For these types of ground, the most appropriate auger head is selected, and piling is performed with pre-augering press-in by the pile auger. In pre-augering press-in, pre-drilling procedure by pile auger is carried out without sheet pile. The pile auger is engaged by the casing guide with leading interlock of the previously installed pile, so that it is possible to accurately pre-auger only the necessary area for installing the subsequent sheet pile. Therefore, press-in is made possible for boulder layers and bedrock layers. Apart from this standard equipment, we're also developing piling management systems and press-in systems that can overcome various types of difficult ground conditions and site restrictions. The offset pile auger enables us to execute coring press-in in ground conditions which previously required pre-augering, dramatically improving piling productivity. The down-the-hole pile auger performs piling while breaking up underground obstructions, such as medium hard and hard rock. The biaxial rotary-driven casing auger increases the excavation efficiency for cobblestones and boulders. Gekin's handling system can overcome headroom obstructions, such as overhead electric cables and bridge girders. The Environmental Monitoring System, EMOS, can monitor and control crush piler movement noise and vibration at piling sites in real time. If any predetermined factor exceeds a limiting value, warning buzzers alert the controller or the crush piler is automatically stopped. EMOS can control the safety and accuracy of the pressing work at any site that has hard ground restrictions. The hard ground press-in method has been used in not only Japan, but has provided construction solutions to difficult ground conditions and site restrictions all over the world. An example here of a project in Hong Kong. Sheet piles were pressed in through layers with boulders over 1.5 meters in size. In Japan, piling into the bedrock layer, which exceeds a uniaxial compressive strength of 166 Newton per square millimeter. In this revetment reinforcement project, steel piles were pressed in through an existing concrete revetment. It was unnecessary to remove underground obstructions. 33-meter-long sheet piles were pressed in at sandy gravel ground for a deep foundation in railroad construction work. Such long sheet piles can be pressed in. Abroad, the hard ground press-in method has to overcome environmental issues such as noise and vibration, where these are highly restricted. Sheet piling adjacent to an active railroad. The safety aspects of the hard ground press-in method has been highly recommended in such environments. This piling project is in the Sherutoko National Park. For this project, the environmental impact was highly considered, as construction work was inside the World Natural Heritage Site. The piling work was performed under strict regulations to protect the natural environment and the native wildlife. As shown, the hard ground press-in method is unhampered by severe soil conditions and various site restrictions, and leaves numerous project achievements. The history of foundation work has been battles against problems that must be resolved, such as hard ground conditions, surrounding environment, and safety. Based on the coring theory, Gikin's hard ground press-in method successfully overcomes those problems without losing the advantages of the press-in method. It will rewrite the history of foundation work. This is the method that will solve the various problems that construction works face today.